Okay, so welcome to the this UBC BRIMM webinar. My name is John Steen. I'm the director of the Bradshaw Research Institute for Mining and Minerals, otherwise known as BRIMM. We're very pleased to present this work today because it's something that the industry is really pushing towards. We see ICMM having standards around and promoting nature positive mining solutions. While we see a sort of backtracking a little bit on climate action in the mining sector, which is regrettable, we do see a lot of interest in things like biodiversity and nature-based solutions still. So I'd like to acknowledge, following from that, that we are on the traditional and unceded territories of the Musqueam, Squamish and Tsleil-Waututh First Nations. And a lot of this work is in collaboration with other nations, particularly in British Columbia, but also across Canada. So we thank them for their collaboration and support. Our speaker today is Dr. Greg Paradis. I've known Greg now for about 3 or 4 years. Greg is a professional forester by background and completed a late career PhD and is particularly gifted in terms of data analytics. So he brings a really interesting combination of practical forestry, land management, plus the analytics that come with all the tools, machine learning, AI that we have at our disposal these days. I think it's timely for this work because we're seeing a lot of companies making sort of high-level commitments to nature-based solutions, but really struggling to quantify and make objective decisions on which are the best investments. So we're really proud of this work, and I'll hand it over to Greg. Thank you.
Thanks, John. And thanks, BRIMM, for hosting this webinar and also for including me in the research program. So I am, besides being the presenter today, I also lead the Natural Capital and Biodiversity Research theme at BRIMM. And we're very much looking to expand on that theme and continue the work going forward. So this isn't a done deal. In fact, we're just getting started. We're breaking ground in almost all aspects of the work I'm going to present to you today with respect to the connection between industrial mining and industrial forest management activities. There's really a non-existent connection between those things, either in research or in practice. So we are building bridges, links, and concepts and proofs of concept as we go. However, I'm trying to base what we're doing in solid foundations that we're comfortable are a good base. So the title is Nature-Based Solutions in Mining Using Decision Support Systems to Guide Action. A lot of the work I do in my lab starts with the idea of decisions. And one thing that guides everyone who makes decisions, whether it's in the mining sector, in the forest sector, people don't always agree. Lots of different people work for different institutions, have different objectives, and there's a lot of disagreement, but there is some agreement. And one thing we all agree on is the concept of sustainability. Everyone I know in this space agrees that sustainability is a good goal and we should strive to that. And so how do you get there is with a sequence of sustainable decisions. How do you fail to get to sustainability is with a sequence of bad decisions. And so I build simulation and optimization models that simulate systems that are fundamentally structured around the decisions we make and how they interact with natural and anthropogenic systems. So next, sorry, I'm trying to switch my slide here. There we go. So I'm going to do a quick recap on the idea of nature-based solutions and more specifically its incidence on the mining sector. and some recent trends that John was alluding to. And then I'm going to transition into some recent work we've done to model these nature-based solutions as decision support systems. And then I'll end with some prospective thoughts of where we could or should go next, and invitation to discuss, ask questions at the end of this webinar. So first off, just a little context summary here. What's the incidence between the mining sector and decarbonization commitments? So mining companies writ large are announcing voluntary commitments to net zero, net negative, or at least net low number carbon emissions by 2050. And as John said in his intro, there's been some recent vacillation and softening of some of those commitments, but I think that's understandable and to be expected as companies find their footing in this space and figure out what it is they really want to commit to and on what timeline. Up to 90% of the emissions that mining companies are currently contributing to the atmosphere could maybe be reduced or completely eliminated through internal activities. For example, better energy efficiency, switching to zero emissions vehicle fleets in the mining operations, switching to renewable power generation, better energy storage, etc. And there's a whole BRIMM theme that looks at those issues, and if you haven't already, reach out to them. They're doing some great work, and it's promising. However, we can't plausibly get all the way to net zero just through internal efficiency measures. No matter how much engineering and budget we throw at it, there's going to likely be an emissions gap. We're not going to get all the way to net zero. So that leaves at least 10, if not 20, 30, 40% of current mining sector emissions that could only be achieved through, it could be the purchase of carbon credits or other net negative carbon activities that are in addition to current operations. So we have to go outside of current operations and outside of just being more efficient to get all the way to zero. So it's predicted that if you want to just purchase carbon offsets on a voluntary market, the future price of that between now and 2050 is really hard to say, but it's likely going to go up, and possibly by multiples, and that makes it difficult to budget. Here's a graphic from a recent 2020 BRIMM white paper showing that the mining sector can achieve a large energy and carbon emission reduction through, again, like I said, efficiency, zero emission vehicles, renewable power, energy storage, and such. But, we might need to engage in, for example, carbon capture and storage, or carbon removal, or some other type of activity. And other could be nature-based solutions that are sequestering new carbon in the forests that are adjacent to the mines that we're attempting to bring to net zero. And that's the focus of the work I've been doing at BRIMM for the past few years. So nature-based decarbonization solutions, for example, capturing carbon in forests or wetlands or the soil, could become an essential part of carbon capture portfolios for mining companies to achieve their commitments. Could be. It's not really a very large part of their investment portfolio yet, but there is interest, and BRIMM thinks this is a really promising area. To date, there has been limited research into looking at the value creation linkages between forest sector industrial activities and mining sector supply chains. What I'm trying to say here is that mining sector and forest sector industrial resource extraction activities and the companies that engage in those activities are and always have been neighbors on the landscape to a large extent, especially in Canada, where most of the country is covered in forest. Therefore, most of the mines are underneath the forest, yeah? And so I feel like there's a really good potential there that hasn't been fully explored. So some recent work that we've done has looked at the use of biochar, for example, derived from harvested fiber residues, and those could be used for mine site reclamation. And there's all sorts of fun stuff we could do. We could also look at nature-based solutions for closed mine sites. For example, bioenergy applications, maybe potential for actually generating forest carbon offset credits above and beyond net zero, or the carbon impacts of these nature-based projects on the forest sector supply chains that operate in the area, or the life cycle analysis of the forest or mine products that are derived from the extraction activities, or circular economy topics, or other Industry 4.0 type digital twin or other approaches. So there's a lot of potential for new research at the intersection of those two, forestry and mining resource extraction activities. So how would we connect forest and mining sector activities? Again, the connection hasn't been made almost at all, either in practice or in research. So what I'm sharing now is my lab and my collaborators' ideas. We're just getting started on this. So we very much encourage and value your ideas. Come forth, ask questions at this webinar, reach out. We're not done with this. So in particular, there hasn't been a lot of research focusing on the logistics and business model aspects of these potential linkages between the forest sector and mining sector supply chains. However, in the real world, net negative carbon offset projects that are sold as carbon credits on markets, the economics and the business is a huge part of what explains which projects actually break ground and which just stay parked as potential projects for the future. Carbon projects have to be profitable internally. I think it's essential, if we're talking about net zero and climate change mitigation, that we proactively include cash flow and business and logistics considerations from square one. Otherwise, I think we're misrepresenting the entire system and what drives it. So the potential for nature-based decarbonization in the mining sector is largely hypothetical and undocumented. We're trying to start to document and nail down a few things using some simulations and other data points, but we're just getting started. So the mining sector could potentially benefit from having access to a list of potential nature-based projects that they could invest in that would arguably result in a climate change mitigation effect. In other words, a reduction in net carbon emissions, and have a magnitude, have a number of tons of reduced emissions that's a large enough number to be able to put a dent in their 10% unreconciled net zero goal that I spoke of in the introduction, as well as a unit cost in dollars per ton of CO2 equivalent that matches what they can afford, or at least what they're willing to pay. But also, it's essential to look at the environmental, social, and economic side effects of these carbon projects, and make sure that overall it's a net positive project for sustainability and not just negative carbon emissions, but at the expense of a social or environmental indicator that we also care about. Otherwise, we're just creating a new problem to solve this one, and we haven't arguably made any net forward progress on our sustainable aspirations. So this information, if it was available, could be used to rank potential nature-based decarbonization solutions or investments, and to focus investments in the real world, but also research in academia on the most promising opportunities. And so the work I'm going to present today that's been done with modeling in my lab in recent years is building a framework, a simulation framework that's capable of doing those things, that's capable of simulating various nature-based solution scenarios on large extent of forested land that could be in the middle of nowhere or could be adjacent to a mine site, which is what we've done, and to evaluate in multiple different axes, environmental, economic, social, the impacts of these various scenarios, and see if we can't find win-win-win scenarios that have an acceptable unit price and, again, an interesting magnitude or volume of sequestered carbon. So this slide's just here for inflammatory purposes, just to get everybody a little bit wound up. I don't believe this is necessarily accurate, but Bloomberg in 2022 published a headline that the cost of 1 ton of purchased carbon offsets, those same tons that a mining company could elect to just purchase off the open market to reconcile that last 10% gap in their net zero commitments, could rise by as much as 3,000% relative to the 2022 price by the end of the decade. So maybe that's true, maybe it's not. But I think what is true is that the future price of 1 ton of carbon offset is potentially highly volatile and difficult to predict, which the combination of those two things is bad news for making budgets for achieving net zero goals by mining companies. So we're proposing that mining companies, if they want to achieve their net zero objective and close that 10, 20, 30% gap that they're not able to close through internal energy efficiency measures, I think the mining sector should strongly consider directly investing in carbon projects that they believe are promising and that will yield the tons of carbon net emissions reductions they want and need at a price they are interested in, and that they have a controlling stake in those projects so that they can control the implementation, the outcome, and start bringing this price volatility and uncertainty under control by, again, directly investing instead of just being a victim of microeconomic price elasticity of supply and demand for these carbon offset credits makes the price ping pong all over the place. So forestry carbon offset price and co-benefits vary depending on what type of nature-based solution we're talking about. So, whether we're talking biogas, water filters, cook stoves, wind, or forestry, there are very different portfolios of impacts across different sustainable development goals, or SDGs. So all nature-based solutions are not created equal. And the system, the simulation system, and the modeling approach that my group's taken in recent project has taken that into consideration, where we're trying to explicitly track and report on the impacts of carbon mitigation projects, not just in terms of carbon, but in terms of a range of sustainable development goals. So the role of an impact of these carbon projects that the mining sector could be ramping up and investing in the future is almost certainly going to touch First Nations communities who are also present on those same forested landscapes under which we are mining. So I think it's just essential that we name First Nations as an intended partner, and that the impacts on First Nations communities are part of the output of any analyses we do right from the start. So I think there is an opportunity if we engage with First Nations as partners to generate social and economic benefits through engaging in nature-based solutions that generate carbon emissions reductions that the mining sector is interested in, but that also potentially have some co-benefits in terms of cultural reclamation, improving biodiversity, improving ecosystem resilience to climate change, and other stuff. However, I don't think you're going to get those types of projects accidentally. I think it has to be very intentional. I don't even know if it's possible to achieve all those things simultaneously, but if you're going to achieve even multiple of those things simultaneously, I think projects have to be very carefully designed from the start to do so. And that requires a systems approach to planning and modeling these solutions where you capture the entire system and all of the side effects of any given scenario right from the start, including side effects on cultural, social, and stakeholder activities and perceptions. So just, a relatively recent data point in British Columbia in February of 2022, the BC Assembly of First Nations published a discussion paper making a case for nature-based decarbonization projects led by First Nations communities. So this isn't a new idea I'm bringing forward. I'm piggybacking off of a signal that British Columbia First Nations communities have already emitted. However, I don't think there has been a tremendous uptake yet, but there's obviously an opening and an invitation. And some of the limitations or impediments or barriers to these First Nations-led nature-based decarbonization projects materializing that are identified in this 2022 discussion paper include defining land tenure and carbon rights, tensions in shared territories, substantial capital requirements, resource and time requirements, and project risk management. Now, I'm not saying the mining sector can fix all of these things. However, I think a well-designed collaboration with the mining sector could definitely alleviate tension in terms of capital requirements. Mining sector could obviously be a cash investor if they chose to. They could also contribute in kind resources and time to making these projects go all the way through to breaking ground. And one thing that the mining sector is extraordinarily good at historically is risk management. Mining is about managing risk. And so if that's a thing that these First Nations communities are struggling with in getting nature-based decarbonization projects off the ground, I think the mining sector could just contribute its expertise, just repurposed to a new target. And thereby, I think, put a big dent in these barriers or challenges that are currently preventing First Nations communities from engaging in in nature-based decarbonization projects that they have signaled they would like to see more of. So I'm going to close up this sort of nature-based solutions intro or context presentation by saying that the climate crisis requires immediate and decisive action. It's happening now, so it's kind of a now problem. Investments now would be much better than investments, say, 50 years from now, when it may in fact be too late for many things. The mining sector is many of the larger players in this mining sector have committed to net zero carbon emissions targets by 2050. So that's great, but acting on those and rolling out very specific plans to get there is still very much in the planning phase and not always fully publicly declared yet. So it's a good time to get in there and have conversations with mining sector partners who have committed to net zero and aren't fully sure how to get there if they want to engage in some nature-based solutions as part of that portfolio of investment. Mining sector actors could extend their current business models to include carbon capture. They could just make carbon capture part of what they do. I don't know if they should do that, but it's an option, and that would, I think, make it clear that they need to then develop and deploy the capacity to do so, which would involve directly investing in carbon capture projects, like I mentioned earlier. Nature-based solutions linking forest sector and mining sector industrial activities, I think, have huge potential. Again, because they are geographic neighbors on the landscape in Canada and elsewhere, and because they're both in a resource extraction space, and also because they literally share large segments of rural resource roads and unpaved road networks and other things. They're neighbors. I strongly believe that a systems analysis approach is essential to getting where we want to go with well-designed nature-based projects that achieve not only carbon benefits, but co-benefits in terms of social, economic, environmental, and First Nations reconciliation goals. And those co-benefits should be intentionally built into the projects, I think. Purely carbon-focused projects, I think, are in fact likely to have negative impacts on those other sustainable development goals, and then we're possibly making more of a mess than anything else. And First Nations must have a key role to play in this, and so we need to be engaging them from square one. So moving on to recent work, we did a project where we simulated various forest management scenarios at the landscape scale in the area surrounding 3 different mines that are owned and operated by Newmont in British Columbia as a case study and a proof of concept of what a open source decision support system that simulates various nature-based solution scenarios in realistic scales of landscape could look like, and what the types of output are. And it's also very much an exploration of how to capture and present the output of that exercise, that modeling exercise, in a way that is converging on what a mining sector investor would need to start to identify types of projects they might want to invest in a given area. So the theme at BRIMM launched in 2024. We're currently at the end of a 3-year trial period, and we've mostly been spending money on hiring a part-time research associate who's been involved with the project I'm going to present here. So Newmont, our partner, along with Mitax in this project, has declared a net zero carbon emissions goal. So is an example of one of those carbon leader companies that I was referring to earlier. Now, here's just an excerpt from their 2021 climate report, where they show a trajectory, a declining trajectory of carbon emissions over time. And even there's a little bit of gray at the far right-hand side under the zero line, showing that, they could even get to beyond net zero and go to net negative if they just keep going, which I think we should just keep going. If you get really good at sequestering carbon, why stop at zero? Just keep going if you're good at it. And so it shows a similar portfolio of activities, including electrification of equipment and efficiency measures to reduce energy consumption in mining operations and a processing of ore, as well as investment in nature-based solutions and carbon capture utilization and storage. So we're trying to zoom in on that nature-based solutions bubble and furthermore zoom into the forestry-specific nature-based solutions that might be available in the forests that surround Newmont's mines in British Columbia. Because these types of projects, you have to go beyond hand waving at some point and get down to specific case study areas before you get anywhere. So just sort of a quick pictogram of forestry and how it's involved in carbon cycles. Forests do draw down carbon from the atmosphere when trees grow through photosynthesis. We pull greenhouse gases out of the air, and trees just transform them into basically wood. Yeah, that's the short version. And that wood continues to sequester carbon until the trees naturally die or are killed through fire or insects or blowdown or one of the many other natural disturbances that occur in the forest. Or when we harvest the trees, they get shipped off to a forest sector supply chain where they get turned into stuff. And some of that stuff, for example, tissue paper, has a very short half-life, and for all intents and purposes, that carbon gets emitted back into the atmosphere almost instantly. Longer-lived wood products, like cross-laminated timber, lumber, and other products that have large amounts of wood that go into, for example, the Forest Science Center, where my office is, right here, where I'm speaking from. That whole building is built from very large pieces of timber that will likely be part of this building for the next 100 years. So some forest products do sequester carbon for a very long time. Others don't. And when the forest products get to the end of their life cycle, they are either recycled, reused, or dumped in a landfill, and they have a different emissions profile after their primary life cycle phase is ended. We can also take residues or recycled wood products and grind them up and burn them and turn them into bioenergy, either through just making heat and turning that into steam and electricity with a turbine, or through pyrolysis, for example. We can transform cellulose or ground up wood into biodiesel or biochar or some other interesting products that, again, have an incidence on climate change mitigation and carbon balance. So that's how forestry can contribute to nature-based solutions for decarbonization, not just for the mining sector, but just in general, is by manipulating that cycle that I just showed on the previous slide. So what we did in our project was we compiled forest landscape level simulation models for 3 sites, where those sites are, again, geographically surrounding 3 mines that were actively managed by Newmont at the time the project went through, which is the Emerald Jersey Mine, the Equity Silver Mine, and Golden Bear Mine. I'm just going to show you here the map for all 3 on the left-hand side of the screen, where the Golden Bear, or Case 1 mine, is the one that's the farthest north. In the top left corner, and it's shown in more detail on the right-hand side here. And what we've done when we have, when we said management intensity zones 1, 2, 3 on this map, what we did is we used the concept of the watershed as the natural spatial unit of building the areas around the mines. So we took the watershed where the mine is located in, and we called that management intensity zone 1. So if you wanted to invest in carbon nature-based solutions around your mine, probably start with the watershed where your mine actually is, because that's the highest impact area. The ring of watersheds around that first watershed is our management intensity zone 2, and the ring of watersheds around that is management intensity zone 3. So that whole area is the whole gray sort of footprint there is the forest around the mine, where the Golden Bear Mine is approximately in the middle of that. However, it's a very mountainous area of British Columbia, and to a large extent, The forest in that area, the gray stuff, is not industrially managed or harvestable for various reasons. It's inaccessible, it grows too slowly, it's off limits because it's protected or whatnot. So in those areas, if we don't have the capacity to take actions or to change the actions we're taking, we can't do a carbon offset project because carbon offset projects require a deviation or a departure from business as usual. So if there is only one possible future, then there is no departure from business as usual possible, and therefore there's no carbon project potential. So the green and yellow area is the residual or timber harvesting land base, which is the same area that, for example, the Chief Forester of British Columbia would use to determine allowable annual cut levels for how much wood forest companies are allowed to harvest on an annual basis. So we solved this as an optimization model. I'm not going to decode all the math, but if anybody gets the slides afterwards, they can see that we've used a very simple, basic Model 1 formulation to optimize maximum harvest levels that are also even flow and sustainable, that also meet various constraints. For example, having a certain amount of old growth or having certain age class distributions, or just making sure that certain other things do and do not happen on the landscape. So this is a classic optimization model formulation that has been used actively to plan forest harvesting activities at the landscape scale since the 70s. We're not innovating here at all. This is the most basic way you could simulate when and where harvest activities and other activities will happen on the landscape. So we did that deliberately. We're not looking to innovate in terms of how forestry is done. We're looking to innovate in terms of making new connections between classic forestry and new commitments of the mining sector to possibly invest in different or improved forest management. The model itself involves collecting quite a tremendous amount of data and pre-processing it, shoving it through, and getting the scenario output that I'm going to show you in a minute here. However, all of the data that we've used in this study is publicly available. All of the post-processed model-ready inputs that we used in our simulations are also publicly available, and all of the output is publicly available, and all of the code and documentation of how to run that code is also publicly available. Everything is fully open in this study, and we're trying to make a point of doing that in all of the BRIMM projects that we're leading in the in the natural capital and biodiversity theme. And I think that's really, really important, but it's also a lot of work and an expensive way to do things. So the scenarios we ran include testing timber maximization versus carbon maximization. So traditionally, the forest sector is just looking to get as much timber as possible. But what if we wanted to capture as much carbon as possible? How do those two scenarios differ? We use basically an industry standard timber harvesting land base, but we also looked at some alternatives for timber harvesting land base in case that offered up potential avenues for nature-based solutions that haven't been explored yet. We also looked at biodiversity and wildlife prioritization schemes, management intensity zones, and some ecosystem service prioritization when we built our scenarios. And there's so much more we could have done. I'll list the stuff I would like to do at the end of this presentation, but we're just getting started. So some quick results from having run our model. I just want to show here that the lines pointing downward below zero are negative net emissions. So it shows that almost all of the scenarios we ran for case study area 1 around Golden Bear Mine had negative net emissions, but some of them had much higher negative net emissions than others. So our model is capable of capturing the response of various management policies and assumptions about how things will go down in the future in terms of the emissions at the landscape scale. So that's great. That was a success. Check. In order to do this, we had to integrate at the software level the basic software for doing the wood supply modeling, which is WS3, an open source software platform that we developed in the Fresh Lab, with CBM, which is a carbon budget model that's developed by the Canadian Forest Service. So we had to glue those two things together and get them to be friends and talk to make a graph like this happen. Now, we can also see that there's quite a range of responses in our scenarios that we modeled in terms of old growth attributes. So if that's something we're interested in, old growth seems to be very highly correlated with carbon emissions in our study, the way we did it. However, our attempt to capture the idea of biodiversity using tree species diversity it wasn't a flop, but the signal was very weak. So I think we need to keep looking in terms of developing a good set of metrics or performance indicators that capture the response of our forest system or our ecosystem in terms of biodiversity. This isn't really telling us much. In this graph, I'm going to show you 3 slides back to back. This is the net emissions of carbon over time for the next 100 years across various scenarios for mining site 1. So you can see that even inside of mining site 1, those 4 different panels are 4 different objective functions or ways of optimizing and describing to the model what it is we want from the future. We can get anything from largely negative emissions to largely positive emissions, depending on which way we point this model. So it's quite responsive. So that's good news. But even across time, you can see that, the carbon emissions, they go up and down, and it can be quite a lot to process. Also, those different colored lines, those are 10 different scenarios we ran inside of each objective function formulation. And you can see that the range is quite large, even within one objective function and one site of the response of various scenarios. But the good news is that it's not random. There's a pattern there that we were able to decode and report on in a paper that we're writing. This guy versus this guy. These are just different sites. This is site 1, this one's site 3, this one's site 2. So again, we weren't able to come up with a single unilateral conclusion of what is a good versus a bad scenario or plan that fit across all 3 sites and across all possible definitions of the objective function. So that's bad news for anyone who wanted just like a really quick and dirty answer to what should the mining sector do to decarbonize using forests. But it's great news in terms of a decision support systems-based solution being the answer to getting some insight about this. The fact that our system is producing a coherent and analyzable and reasonable response across various scenarios on various sites is indicative that we should keep going in this direction. Presenting the output from these models is, I believe, the #1 challenge that we still have yet to fully nail in this line of inquiry. The volume and the dimensionality of the data that we produce when we run these models is very high, and it's just super challenging to find a way to capture the output of these models in a way that makes sense to people who are not forest ecosystem and forest sector supply chain modeling experts. One attempt is these kind of radar charts that show the response across 5 different indicators for 10 different scenarios for 4 different objective functions. But again, we've made some attempts at actually explaining these graphs to various people, and largely the response is that these still need a lot of work. These are hard to interpret. But what I can tell you is that we are getting a really interesting range of responses across sites, scenarios, and objective functions with our new system. So it's working, and I think we should continue along these lines. So in summary, for our project that I just showed you, it was a 1-year project, a joint Mitacs Newmont grant, where we had a single postdoc working on this. The project was completed. We were in discussions about a renewal for a 2nd year with Newmont. They discontinued those discussions because I'm not super sure, but I think they were having some internal administrative reorgs at the time, and we know we're no longer a priority on their radar. We're still looking for an industry partner in the mining sector to continue this work. We think there's lots of interesting work that was left on the table that had to be paused. We had some success getting our postdoctoral fellow a Women in Mining Research Fund grant. So I think the impact of the research we're doing was recognized by some mining sector instances with an award. And the workshop component, where we were supposed to take the scenarios I showed you today and spend 1 or 2 days unpacking that output for mining, forestry, and other experts to elicit feedback, take that feedback using a structured social science approach, compile it, and then inject it back into our model to get a second round of scenarios that included the feedback. We never did get that workshop component done, but I believe that there's a lot of value latent there, and that we should in fact engage in that work. So what's next? I think we need to move beyond prototype analysis and towards an operational, continuously updated decision support platform that is usable in practice. We're not there yet. There's a lot of work to be done, but I think the foundation we've laid is a good start, and we should continue to build on it. We want to expand beyond carbon-only accounting to a more integrated ecosystem services and cumulative effects assessment platform. I'm currently working on that in collaboration with some people at the Predictive Ecology Collective at the Canadian Forest Service, and we're making good progress on that. I think we should also incorporate some more complex management actions into the simulations that I presented to you today, including some restoration, reforestation, wildfire risk mitigation, bioenergy and bioproduct pathways, adaptive silviculture, and all of those things are, I guess, in the works for either ongoing or soon to be deployed projects in my lab. Also, I think we need to improve the spatial realism and the temporal responsiveness of our model using, for example, remote sensing, LiDAR, or data assimilation workflows. And that's a huge amount of work. So it's more of an aspirational goal. We haven't broken ground on any of that yet, but I really would like to. We also need to develop participatory planning workflows with mining companies, First Nations, governments, local communities. And that's very much outside the scope of the work that I presented today, but very much complementary to it. We also need to evaluate the economic feasibility, carbon credit markets, implementation risk under real-world policy and operational constraints. And that's a whole rabbit hole in itself. We haven't made much progress on that, but I think it's essential that we launch into that direction as soon as possible. I also want to be able to extend the simulation and modeling framework I showed you today to include better biodiversity objectives. Like I said, the one we had in there were somewhat weak and unresponsive. We want to include new indicators for watershed resilience, cultural values, climate change, adaptation, and other things. But doing any one of those things is a whole project in and of itself. Transition from a sort of notebook-based prototype towards a more usable piece of software that matches expectations of professionals in practice. I also want to build transparent, reproducible, and auditable workflows that support evidence-based decision-making across the sectors. And that last one we can't really get to until we've done some of the stuff above. So in closing, everybody likes a punchline. So here's a punchline. It's not necessarily the punchline, but it's a punchline. I believe that nature-based decarbonization is ultimately a systems design problem. It's not a carbon accounting problem. Carbon accounting is not a problem. The people who know how to do it know how to do it. This is fundamentally a systems design problem. So I think we need systems analysts and people with systems views to be involved in work going forward. So if that is you or someone you know, please get them in touch with me, and we can talk about how we can work together. So that's that for my presentation. Thank you for your attention.
Thank you, Greg. That's a great presentation, very, very detailed. We have just a couple of minutes for questions, or are you happy for people to follow up with you, Greg?
Well, I mean, I'd gladly take questions now, and also would love follow-ups after, yeah?
Sure. So, yeah, over to the audience.
I have a question, John, or Greg.
Yeah.
I was wondering, you talked about a little bit earlier about how it was important for First Nations to be involved in this type of a project. How do you see that happening in, like, would you say in the gold bear mining scenario? I'm assuming that's within a nation. And I was wondering if you'd had any interactions with people from that community who are, around the vicinity of the mine.
Not for that case study. So the case study we did was largely just conducted using publicly available data plus some data provided by Newmont as sort of a proof of concept of how we would go about this. We did not visit the site or directly engage with the stakeholders, including the First Nation. But that thing you said, Bernadette, I believe is the first step. Find out whose territory your project overlaps with. And there's often more than one First Nation community that their territories overlap, right? And find out who those communities are. Go introduce yourself. Tell them what your aspirational goals are. Find the intersection with their hopes and dreams, and then identify a desire to build a relationship of trust with them, and then ask them how they would like to go about that is what I believe is the correct process and the correct first step. But I think that always requires a long lead time. You need time. So if anybody thinks they're going to want to be doing this, I think they need to start that building a relationship of trust with their First Nations immediately. Just get to it, because the sooner you start, the sooner you're done that lead time. So I don't know if that, I'm not dodging your question.
No, I understand. Yeah.
And I think the other building, I think, is the crux of the whole thing. Yeah.
Right. And I guess the other part of it is that I understand this is the first phase of sort of model building and understanding the different parameters. But a lot of the results are very technical, and as you say, they're super challenging to visualize for lay people. So it might be worth thinking about collaborating with somebody who is some experts in data visualization to see if there might be some ideas in that. So I'll have a look at that for you.
That would be great. And there's some sort of parallel work that I didn't present here that I've been working on for several years, but it's a bit of a slow grind to come up with completely new ways of presenting and talking about multi-dimensional data like this that involves some new applications of machine learning to basically flatten five-dimensional data sets to a five-sided polygon, and then we can have a conversation about it. But I'm not ready to reveal that because it's
that's okay.
But yeah, I totally agree with you. More investment and acceleration of that part of the research program would allow this to become useful much sooner.
Yeah. I think there may be some other questions. Thanks, Greg.
If where do we see the questions?
Dana, do you have?
Dan,
We
the
have a
Q&A
few.
button. Yeah.
We have a few comments in the Q&A, but they're just people just saying thanks and hello. Something about the link to the presentation available. Yes, we will be posting this online, and this will be available for everyone to view afterwards.
Yes, for sure.
I think that's all we have, actually. I don't see anything else.
I think it's all. So it's the top of the hour, so we might wrap it up here. But thanks very much, Greg, for your work. I think looking into the future, this will become more and more important. So it's good to be ahead of the curve sometimes. And we really hope to be working with industry, First Nations, government on promoting this work and getting better at it. So thank you very much.
Thanks for having me, and thanks to everyone who chose to join us today.
All right. Okay.
Thanks,
Goodbye,
Greg. Thanks,
everyone.
everybody.
Thank you.
Thank you.